We're going to begin working through a couple different situations with our integrals, and that deals with your even and odd functions. And if you remember, an even function is symmetrical along the y-axis. So if this reflects, it would be the exact same graph. And then our odd function is a reflection around the origin. So visually, if you rotate this thing 180 degrees, it's going to be the exact same graph. So if you happen to have an even function and you're going from the same value from a negative to a positive, basically those areas are going to be exactly the same. And so really you could actually do half of it, go from 0 to that value, and then just multiply it by 2. You don't have to, but if you happen to recognize, you might save a little bit of time and a little bit of effort. And then an odd function, you're going to save a lot of time because an odd function is going to, if you get, again, from a negative a to a positive a, those areas are going to be opposites of each other. So you're going to have a positive area and you're going to have the exact same negative area. And so they're going to undo each other and cancel each other, and you're going to get a 0. So if you recognize that, you're going to definitely save some time to it. So let's take a look at two different examples. So right here, in order to have an even function, I have potential, right, an x to the 8th. So visually, I have a graph that's dipped down 2, and it has an x to the 8th, so it has a quadratic-ish kind of a field to it. It's an even function. So really, all I have to do is go from 0 to 2, find the area of the right side, double it, and then I'll have the overall area. So let's go through, finding the area under this curve. All right, so to do the antiderivative, we're going to add our power and divide by that power. So we're going to have a 3x to the 9th divided by 9 minus 2x. And we're going to go from 0 to 2. So we're going to have a 2 plugged in. Let's simplify it a little bit. This is going to give us a 1/3 x to the 9th minus 2x, 0 to 2. All right, and then let's start to plug this in. So we'll plug in 2, and so that's going to be a 1/3 times 2 to the 9th and minus 2 times 2. So there's the first chunk, and then minus 0, because we're plugging a 0 in, so that's just going to be a 0 minus a 0. So let's figure out what this is. We're going to subtract 0, so that's not going to do anything. So 2, this is 2 to the 9th is 512. So you're going to have a 512 thirds minus 4. Let's start putting it over 1, and then minus 0. We can drop that. So now we're going to have 512 thirds. That should be 12. 512 thirds minus 12 thirds is getting us 2 times 500 thirds equals 1,000 thirds. And that's the area for both sides. 500 thirds was the area for the right side, and then the area for the left side was over there. So that is our area. Kind of simplify the process a little bit, because rather than plugging in a -2 into this all over again, we were able to plug in a 0 and just get an area, and then we can just double it. So if we have an odd, if I recognize that this is an odd, might be something like this. If I recognize that this is an odd, really I can just say my area is going to be 0 because they're going to cancel each other, but I'm also going to go through the math to show that that actually happens. So if we do our antiderivative, we're going to add our power, divide by our power, add our power, divide by our power, and we're going to go from -2 to 2. Right, so let's plug in. So we'll do 2 to the 4th over 4 plus 2 to the 2nd over 2 minus -2 to the 4th over 4, right? And then plus a negative 2 to the second over 2. And we're looking at 2 to the fourth, 2, 4, 8, 16. So 16 fourths. Hold on, so 2, 4, 8, 16. 16 divided by 4 is 4 plus, this is 4 divided by 2 is 2 minus negative 2 to the fourth is going to be also a 16 fourths, which is 4. And then this is going to be a positive 4 over 2, same thing as this. So that's going to give us a 2. And if you're noticing, they're exactly the same. So, but you're subtracting them. So this is going to be a 6 minus 6 equals R0. Because visually, we would have a positive area, we would have a negative area, and they're going to cancel each other away. So that is a couple scenarios. Now, obviously, if you don't recognize that you have an odd function, that you're going from the same number to the same number, if you see a same number to the same number, I kind of want to maybe investigate a little bit more. Do I have an even function? Can I save some effort to it? Especially if it's an odd. I mean, if I recognize it, I can just say the area equals 0, but you can also go through the math and that'll get you there as well.